all of these require us to use the general formula.
Okay.
There's two
Is it?
general formulas for parabolas. There's the general formula for a vertical parabola, and there's a general formula for the horizontal parabola.
Okay.
Okay? What's the first one? Is that vertical or horizontal?
Vertical.
What's the general formula?
Isn't it minus 4AC over...
It's
No.
4p
Oh, okay.
equals 1, excuse me. Here, let me start over again.
No problem.
And I'm not actually positive. I've been having a hard time just determining whether Chatfield uses the 4p notation.
Yeah, I think we do. I've heard it
We do
before.
too, yeah.
Yeah.
And it's y minus k, and that's equal to x minus h squared. Now,
Okay.
the way I memorize this is the 4p goes in front of the term that is not being squared.
Okay.
In other words, this is for a vertical parabola, but if I had something that was x equal y squared, that would be a horizontal parabola, and the general format would be 4p times x minus h equal y minus k squared. Okay, so memorizing the general formula, pretty easy. Just the 4p goes in front of the term that is not being squared.
Cool. That is easy to remember.
And in this case, we don't have a k and an h,
No.
so I can write it like that. So really, it's 4p times y equals x squared. Well, how can I make this look like what we're looking at? In other words, here's the equation they gave us. How do I best turn it into something where I can immediately calculate p?
Would it be 4p times 1/8 x squared?
How do I want to move that 1/8 to the other side. Notice that in the general formula, there's no coefficient in front of the x squared.
No.
And yet in the equation they gave you, they did put the coefficient in front of the x squared. So we want to get rid of that. How do I get rid of the 1/8? Multiply both
Multiply.
sides by what?
8
Okay,
over
so
1.
now I got 8y equals x squared, multiplying both sides by 8.
Okay.
Now I almost have it in the precise format, and it's real easy to figure out p. In other words, 8 has to be equal to what? 4p, right?
Uh-huh.
So p is 2.
Okay.
Okay? And so all I got to do is make whatever they give us look like the general formula. And then I can equate that with whatever its coefficient is. So I would say 4p equals 8. Okay, the focus, directrix, and axis of symmetry. Well, let's look at this. We know p is 2. And we know it's vertical. We also know it's relatively flat and its origin is the vertex, right? And its focus is at 2, 0, 2. Where's the directrix?
0, -2. Ouch.
That's close. The only difference is the directrix is a straight line.
Okay. Oh, and then that's the focus is 0, 2.
Right. The focus is a point, but the directrix is a line. So you need the equation of that line. What's the equation of this line? You're correct in that it occurs at -2. What's the equation of a horizontal line that goes through the point -2 on the y-axis?
minus 1/2.
Y equals minus 2.
Oh, okay.
Horizontal lines are y equals some number. Vertical lines are x equals a number.
Mm-hmm.
I had a vertical line there. That's going to be x equals minus 5 or something. Okay?
Okay.
That's all you have
Alright.
to remember is the horizontal lines are y equals something. Vertical lines are x equals something.
Okay.
Now, the only other thing they asked for was the axis of symmetry, which is also a vertical line. It's the
Yeah.
equation of that line.
Just 0, right?
That's not the equation of a line. That's a point.
Of a line would be y equals mx plus b.
No? What I just said, I said horizontal lines are y equals some number. Vertical lines are x equals some number. So what is x equal to?
X is equal to 0.
Yes. That's the
Okay.
equation of the axis of symmetry.
Okay.
Okay?
Okay.
All right. The next one. It's also a traditional parabola, right?
Mm-hmm. Yeah.
Not much difference from this one and the first problem. In other words, it's y equal x squared. The first one was y equal x squared.
Yeah.
So I know that this is also a vertical parabola, but I also know that it opens which way?
Um, it's a vertical
Does
shrink.
it open
No,
up or
stretch.
down?
Vertical. It's gonna open down. Up. Yeah,
Correct.
down. Yeah.
Down because that's a negative coefficient.
Yeah. I was worried. I was looking at another
So we
number.
know it's
Yeah.
opening down, but first of all, we have to put it into this format.
Mm-hmm.
4py equals x squared. So how do I do that? How do I take that and make it look like the other?
Hold on. Okay, so we would do, would it be 2y is equal to x squared minus 2y?
No. So all you got to do is get rid of that. Put it on the other side.
Yeah, so it'd be, okay, so it'd be 12, minus 12y is equal to x squared.
There you go. Minus 12y equals x squared. And now what? How do I find p?
And then it would be minus 12 is equal to 4p,
Good. P is equal to what?
minus 3.
Okay. And we also know why is p minus? Because we have a parabola that opens down. So to get from P, I'm going to go from the vertex and go down 3.
Mm-hmm.
There's the focus at 0, comma, minus 3.
Mm-hmm.
Now, what's the equation of the directrix?
Um, so it'd be y is equal to 3.
And what is the equation of the axis of symmetry?
X is equal to 0.
Okay. Next one. X equals minus 1/20th y squared. What kind of parabola is this?
This is a horizontal parabola.
Right, because it's x equal y squared instead of y equal x squared.
Yeah.
Well, for a horizontal parabola, what's the standard general formula?
4p times x minus h is equal to y minus k squared.
And we don't have any x's or h's in any of these four problems, so we
No.
don't need to worry about the more exotic general formula. It's just 4p equal y squared.
Cool.
Okay, so again, I have a situation where I have my coefficient in front of the squared term, and I want my coefficient to be in front of the x term.
Mm-hmm.
What do I do?
So it'd be minus 20 y is equal to x squared.
Minus 20 what?
Y.
Okay, I'm multiplying both sides by minus 20, right?
Yeah.
Well, this minus 20 goes away when I multiply it by that. So what am I left with?
Um,
Minus 20x
oh, X, but
equals
yeah.
y squared, which is the
Okay.
format you want. You want your
Yeah.
coefficient to be in front of the term that is not being squared.
Mm-hmm.
So what's p equal to?
So it'd be minus 20 is equal to 4p. So p is equal to minus 5.
What's the directrix, the equation of the directrix?
Um,
I don't need to graph it anymore because we know how to do all of these now.
yeah, so the focus is equal to 0 minus 5, and then the
Hold on.
directrix would be,
You know what? I better draw it. I just realized something here.
oh, okay.
Because it's a horizontal, it does matter
Okay.
what the equation of that line is. In other words, if I draw it,
Mm-hmm.
it's not only horizontal, but it's horizontal opening to the left. Because
Yeah.
notice the coefficient that was in front of the y squared term was negative. And in fact, it
Mm-hmm.
doesn't matter whether that's in front of the y squared or the x term. If you got a negative sign in there, it's going to open to the left.
Yeah.
As opposed to if it was positive, it would open to the right.
Mm-hmm.
So p being minus 5 means what? What are the coordinates on p?
Um, 0 minus 5, or minus 5, 0.
Minus 5, 0, exactly.
Yeah.
In other words, it's different because it's horizontal. In other words,
Right.
before we found p by going up and down, but with horizontal parabolas, we're going to find p by going left and right.
Mm-hmm.
And it also changes the equation of the directrix. The directrix is no longer a horizontal line, it's a vertical line. It's the equation of that vertical line.
Y equals minus 5,
Okay.
or plus 5.
There's 5 on the x-axis,
So x is equal to 5.
x equal 5.
Okay.
Vertical lines are always x equal. Horizontal lines are always y equal. And there's the axis of symmetry. What's the equation of that?
Y equals 0.
Good.
Cool.
54. Boy, they didn't mix these up very much. They're
No.
all pretty much exactly the same kind of problem.
Yeah, same concepts. I think we can move on.
Okay,
Um,
go to 55. Yeah.
yeah,
We want to make sure we get to all of them here.
for sure. Just gotta
Describe
save some time.
transformations. 55, what's happening to the parent function of f of x equal x squared?
Um, wait, so just scratch, so,
So we have a function that's x squared minus 3. How does that differ from x squared?
you subtracting 3. There's a minus 3.
That doesn't have any meaning, Dylan. You have to
Okay.
you have to tell whether it's a vertical or a horizontal. You
Okay.
have to say which direction. So just saying subtracting 3, that's just looking at the function and saying it's subtracting 3. It doesn't say anything about the transformations.
Okay.
But what kind of transformation is that minus 3?
Um, vertical.
Vertical what?
So down 3.
Correct. That's called a vertical shift.
Okay.
Remember, there's vertical shift, there's vertical stretch, and there's vertical
Mhm.
shrink.
Okay.
Shift is the one that does not change the shape. In other words, if I look at my x squared parent function, so all I'm doing is moving it down 3.
Okay.
Same exact shape. Because shifts do not change the shape.
No.
Only stretches and shrinks do.
Cool. Okay.
Even reflections don't change the shape, they just reflect it.
Okay.
Okay? How about 56, what's being done?
56, Well, um,
You want to
how
always start your answer out with either the words vertical or horizontal.
would this be vertical?
No? What's being done to it is inside the function. Every time you have a transformation that's inside the function, it's horizontal. When you
Oh,
have
that
a
makes sense.
transformation that's outside the function, it's vertical. On this
Okay.
one, that minus 3 was completely separate from the x squared. So it was
Okay.
outside the function.
Okay. So
That's
this would
why
be a
I have a
horizontal.
vertical shift. What is
Yeah. Horizontal shift left 2.
good?
Okay.
57. The negative sign is outside the function, so what is it, vertical or horizontal?
Vertical.
And what is it? A vertical what?
A vertical shift. No. Vertical stretch.
Reflection.
Oh, it'd be vertical
There's
reflection.
3 verticals that I mentioned, the shift, the stretch, and the shrink. Well, the stretch and the shrink kind of go with one type of transformation. There is a third vertical action, and that's a vertical reflection. I call it
Oh.
vertical reflection. Most people call it a reflection over the x-axis.
Mm-hmm.
Right? But if I'm reflecting over the x-axis, that's a vertical reflection to me.
Cool.
So by categorizing all the verticals together and all the horizontals together makes it much easier to get a handle on these transformations.
For
Because
sure.
the only thing that matters is are we inside the function or outside the function? 57,
Okay.
we're outside the function. That square is not acting on that negative sign.
Mm-hmm.
So that's a vertical reflection. 58
Okay.
is what?
58 would be a horizontal reflection.
Which is a reflection over which axis?
The x-axis.
No?
Or I mean y-axis.
Right.
Okay.
In other words, I'm not sure your teacher is going to accept a horizontal reflection or vertical reflection. They're going to want to
Yeah.
know which axis you're reflecting it over. The only
Mm-hmm.
reason I like to call it vertical and horizontal is because it goes with all the other vertical transformations because it's outside the function.
Yeah.
But typically, math books do not call that a vertical reflection. They call it a reflection over the x-axis.
Okay.
And this is a reflection over the y-axis.
Mm-hmm.
Notice that the reflection over the y-axis does not change the function's appearance at all.
No.
In other words, it looks exactly the same,
Mm-hmm.
as it should. If you carry that squaring out, you get x squared. In other words, minus x times minus x is plus x squared. So
Okay.
it should look exactly like the parent function, and it does.
Cool.
59.
Alright. 59 would be a vertical um vertical reflection, would it?
No, all
Well, because it.
reflections require minus signs.
Oh, gotcha.
All reflections. In other words, the last 2 problems had a leading minus sign, which is a vertical reflection, and this
Yeah.
has a minus sign inside the function, so that's a horizontal reflection.
Okay.
You can't
So
have
this would just.
reflections without minus signs.
Okay.
Okay? There's no
So.
minus signs here. That's a
Okay.
3 that is outside the function. So is it vertical or horizontal?
Vertical.
Okay? It's not a
And it'd be
shift. It's not a
no.
shift because we know vertical shifts come by adding or subtracting numbers after the function.
So this would be a vertical stretch, right?
Correct. And it's a stretch because the number is greater than 1.
Yeah.
If the number was 1/2, it'd be a shrink.
Okay.
But that's why stretches and shrinks go together. In other words, stretches and shrinks are merely a coefficient of the x squared term.
Okay.
Just that it's a stretch if it's greater than 1, it's a shrink if it's less than 1.
Okay.
So now let's talk about 60. There's 2 things going on. Let's start with
So
there's 3 things
hor
going on, excuse me.
yeah.
Let's,
It's a horizontal shrink, right?
hold on, let's start from reflections
Okay.
because those have to be done first.
Mm-hmm.
If you're graphing it and you don't do the reflection first, you're not going to end up with the right graph.
Okay.
Okay? So also, you might as well go left to right here.
Yeah.
And the first thing we run into is that negative sign. What's that mean?
Yeah. Right. Horizontal.
Is it inside or outside the function?
Oh, it's outside. My bad. So it'd be vertical.
Okay, what's the 1/3 mean?
Shrink.
So that is a
Vertical
reflection?
shrink.
Well, let's call it what it is. I want you to, instead of calling it a vertical reflection, because I don't think your teacher's going to accept that answer,
Yeah.
reflection over which axis? What is a
Um,
vertical reflection?
over the y or x-axis.
Okay, and the 1/3 is a,
The 1/3. Wait, what do you mean?
well, what does it do?
Shrinks.
Vertical shrink.
Yeah.
So what we have here is a reflection over the x-axis,
Mm-hmm.
vertical shrink, and then what's the +1?
Up one.
Vertical shift. You might get away with saying up one,
Mm-hmm.
but you also want to know what it's called. It's a vertical shift.
Okay.
Doesn't change the shape. The one shift does not change the shape. The 1/3 does change the shape.
Yeah.
Shrinks it. Okay, how about 61? What's the leading negative sign do?
That means it's a horizontal. Well, that's
Why are you having problems with this, Dylan? You
I don't know. I'm just confused by it.
got every one of them wrong, exactly backwards.
Yeah.
So all you have to remember is two things.
Mm-hmm.
Adjustments inside the function are horizontal.
Yeah.
Adjustments outside the function are vertical.
Okay.
This negative sign, is that inside or outside the function?
Outside.
So it's vertical,
Yeah.
which is a reflection over which axis?
Over the x-axis.
Okay. What's the -3 that's inside the function doing?
Um, that's horizontal within. So it's being shifted. Yeah, it's being shifted. Shifted right 3 or up 3.
Not up 3.
No,
Horizontal
right.
doesn't go up and down. Horizontal goes
No,
left and right.
right. So it'd be right 3.
Okay, and then finally, what's the +2?
Up 2.
Right, that's a vertical because it's outside the function. So all you have to,
Yeah.
there's only 3 vertical things you can do and 3 horizontal things you can do. So
Okay.
if you determine that you're either inside or outside the function, that's huge because now you
Mm-hmm.
only have a choice of 3 things to pick from.
Mm-hmm.
But that's the most important thing is figuring out whether it's vertical or horizontal transformation.
Mm-hmm.
So you don't want to get it backwards because if you get it backwards, you'll miss all 8 problems.
Okay.
You have to get it correct because you'll be wrong on all 8.
Yeah.
If you confuse your horizontal and your vertical adjustments, you'll be wrong on all 8. That's the one
Okay.
thing you can't do. You have
Mm-hmm.
to do everything outside the function is vertical, everything inside the function is horizontal.
Okay.
Okay, so 62. What's that 2 doing?
That 2 is, so it means it's vertical.
Vertical what?
Vertical shift.
Not a vertical shift.
Vertical stretch then.
Comes from adding numbers at the end or subtracting numbers.
Yes, it'd be a vertical stretch.
Multiplying functions is either a stretch or a shrink, and that's a stretch because it's greater than 1.
Yeah.
What's the +1?
That would be um left 1. Right?
Yeah, but call it horizontal or vertical. I'd like to see you start with those words on every one of these problems.
Horizontal.
Right. A horizontal shift,
Yep.
because it's not a multiplier, it's being added or subtracted from the x,
Mm-hmm.
and it's left because it's a plus sign.
Yep.
By 1 unit. Okay.
Okay.
go ahead and describe the transformation of 63.
So 63 would be a vertical stretch, left 2 and up 1.
All right. I'll live with that.
Okay.
64? Hold it.
Hold
You
on.
wanted the vertex also.
Oh yeah, then the vertex would be -2, +1.
Yeah, because that's in vertex format.
Yep.
It's perfect vertex format.
Yeah.
Okay, how about 64? What's being done?
It again be a vertical stretch.
Start with the first thing you see on the left. That's a minus sign.
Yeah.
Go term by term. Don't figure out the 4. Start with the minus sign, then the 4, then the +1, then the -5. What's the minus sign do?
Vertical, but vertical shrink then?
Remember,
Oh, because it's less than 1.
reflections have to be done first, and all reflections have minus signs.
Yeah, okay.
Either the
So it'd be,
minus sign is in
yeah.
front of the function or it's in front of the x inside the function.
Okay.
And if you see a minus sign in either of those positions, you have a reflection. So what's that a reflection over which axis? Don't call it a vertical or horizontal. Tell me what axis it reflects over.
The x-axis.
Okay, what's the 4 do?
It's being stretched.
Vertical stretch.
Yeah.
Not okay to just say it's being stretched because you have horizontal stretches also. So
Okay.
you got to say the word vertical when you're talking about this, stretch.
Okay.
Okay, now what's the 1 do?
It's being shifted left 1.
Yeah, and you don't necessarily have to say the horizontal because you're saying horizontal when you say left or right.
Right.
Okay, and what's the -5 do?
Being shifted right 5.
Nope.
Or up 5. Why did I say right? Yeah, my bad.
Well, it's not up 5 either.
Whoa, it's down 5. Gosh. Yeah, thank you.
What's the vertex?
And then the vertex would be -1, -5.
Okay. 65.
Okay. So it's outside, which means it's vertical. So it'd be vertical. Yeah, vertical. Well, it's a reflection over the y-axis, or yeah, x-axis.
X-axis.
Yeah.
Remember the picture that I drew. You reflect something over the x-axis. Is that not a vertical reflection?
It is.
If I reflect something over the y-axis, that's a horizontal reflection.
Yeah.
So, but the terminology, the only reason I use the words vertical and horizontal is because it goes with the other 3 types of vertical stuff. In other words, all vertical stuff is outside the function, all horizontal stuff is inside the function. So it's far easier thinking of that as a vertical reflection. And then you can figure out that that means it's a reflection over the x-axis.
Okay.
And if you forget, draw a picture like I did. Just draw anything you want and reflect it over the x-axis. That's a vertical reflection.
Okay. Cool.
All right, so let's start again with 65. We've got a reflection over the x-axis, and then what's 2 do?
The 2 is
And here you have to use the word vertical or horizontal. You cannot get away without using the word.
No, so it would be a vertical stretch.
Good. What's the +5?
Vertical, so vertical stretch. And then it's
stretch.
No, I'm talking about the -2.
What's the +5?
And then being shifted up 5.
Okay, yeah. That's
Okay.
correct. It's a vertical shift, up 5.
Yeah.
I don't suppose you have to use the words vertical and up in the same
Mm-hmm.
sentence. You know, up says vertical. Okay.
Yeah, it does.
Let's go back a second.
Okay.
That's not, or is it in vertex format?
For 65.
Uh-huh. They
It's,
want the vertex on each of these also.
oh yeah, it's not in vertex.
Actually, it is. It just doesn't look like it. What's 8?
Would you just put parentheses over the x squared?
Yeah. So where's the vertex?
Minus 2, 5.
No.
Or 2, 5. 2, yeah, 2, 5.
No.
No.
In other words, the x-coordinate of the vertex is inside the function, right?
Yeah, so just be
Up here in
1 minus 1,
63,
5.
you were looking at this 2, the 2 that was being added inside the function. That's where you're going to get your x-coordinate of the vertex. Well, what's the x-coordinate of the vertex here?
1.
0.
Oh, just 0.
Yeah, it's x minus 0 squared.
Okay. Oh, that makes sense.
And then what's
Yeah.
the y-coordinate of the vertex?
5.
Yeah, so this really is in vertex format.
Mm-hmm.
It's just that you have to know that that's really x minus 0.
Okay.
Okay, and finally 66, what's being done to it?
It would be a, wait, let me see here. So it'd be a reflection over the x-axis.
Where are you getting reflection? I don't see any minus signs.
There isn't, oh, I thought there was a minus. I was looking at the, yeah, my bad. So it'd be a,
I mean, I see a minus sign here, but it's
yeah,
not in
not,
front of x.
yeah, so it'd be a,
To be a reflection, that you need either a minus sign in front of the function, or you need a minus sign inside the x term of the function.
yeah.
You have
So
the
it would be
minus sign
vertical.
there, that's just a horizontal shift.
Okay.
What's the one have to?
It's a vertical shrink.
Good. What's the minus one do?
Which means it's being, shifted right 1.
Good. And what's its vertex?
Um,
And it's in vertex format.
is it, okay.
Uh-huh.
1, comma 0.
Good.
Cool.
All right. That it?
That is it,
Another
yeah.
piece of paper, but we're kind of out of time, aren't we?
Yeah,
So,
unfortunately.
but hopefully we got you straightened out there, and I'm glad we had this session, because you
Yeah, me too.
certainly do not want to mix up vertical and horizontal. You will get every
No.
single one of them wrong by definition, because they're all, you can't mix up vertical and horizontal. That's just all there is to it.
Right. Okay.
All right. Well, Dylan, good luck on your test,
Yeah, thank you.
and enjoy your vacation.
Yeah, you too. For sure.
Yeah.
Yeah.
And we'll talk to
Awesome.
you next semester.
That sounds good.
All right. Bye-bye.
Cool. Bye-bye.